Today we're going to look at operations with complex numbers. Remember, a complex number is anything of the form a plus bi. It has a real part and an imaginary part. So let's get started. First, adding and subtracting complex numbers. We're going to treat them just like polynomial expressions. Put the real parts together and put the imaginary parts together with addition or subtraction. So 3 plus 5i plus 4 minus 2i. I put the real parts together, 3 plus 4, and the imaginary parts together, 5i minus 2i. The next one, number 2, 5 minus 4i plus negative 7 minus 5i. So the real parts are 5 minus 7, that's negative 2, and the imaginary parts, minus 4i minus 5i is minus 9i. If you wanted to, you could take any of these and write them without the parentheses. Because it's addition, there's no distribution needed, and you could just go from there. Now with subtraction, you need to remember to distribute the subtraction all the way through the parentheses. So these I'm definitely going to rewrite. This will be 2 plus 6i minus 1 minus 8i. And that will give us, now combine the real parts, 2 minus 1 is 1, and 6i minus 8i is negative 2i. Let me go back and circle all of these. Number 4, distribute the negative again. Make sure you're doing that. Negative 4 minus 3i. Now distribute. Subtracting negative 6 is the same as adding 6. Subtracting negative 3i is the same as adding 3i. Add your real parts. Negative 4 plus 6 is 2. Add your imaginary parts. Negative 3 plus 3i is actually 0i. If you have to write it as a complex, that's what you would have. And we know that is the same as 2. Multiplying. So for multiplying, these are going to be handled just like we would handle multiplying two binomials. We're going to FOIL. Here it's going to be real important to remember. Remember that I squared equals what? I squared. Negative 1. So let's FOIL. The first is 2 times 3, that's 6. 2 times positive 8i. 3i times 3. And positive 3i times positive 8i is positive 24i squared. Now there's our I squared. So in the next step, I will take care of I squared and use negative 1 in its place. So we have 6. I can add my imaginaries, 25i. And now if I have 24 times negative 1, that's the same as minus 24. So I can combine my 6 minus 24. That gives me negative 18 plus 25i. Let's keep going. Number 6. FOIL. 7 times 7. 7 times positive 2i. Negative 2i times 7. And at the ends, negative 2i times positive 2i is a negative 4 I squared. So we have 49. These two terms cancel each other out. Minus 4 times negative 1. That's going to become plus 4. And so our answer is 53. Did anyone recognize these two as something special? A vocabulary word from chapter 3. 7 minus 2i and 7 plus 2i. These are conjugates. So something interesting happens when we multiply two conjugates in the complex number system. Let's keep going. Maybe stop the video here, try number 7 and number 8 yourself, and then fast forward and check the answers. There we go. Hope you got those right. Just FOIL them out. Now a section on conjugates. So we already have looked at a situation where we had conjugates. A plus bi and A minus bi, those are conjugates. Remember, to write a conjugate, you only change the sign in between the terms. Okay, so the conjugate of 2 plus 7i is 2 minus 7i. The conjugate of negative 3 plus I, whoops, I just gave the answer. Negative 3 minus I is negative 3 plus I. Very good, Mrs. Raccoon. The conjugate of what is 2 plus 2i? 2 minus 2i. And the blank of 4 minus 8i is 4 plus 8i. It's the conjugate, of course. So we run into using conjugates quite a bit. We used a conjugate in chapter 3 to rationalize denominators with radicals in them. And since I is truly a radical, we'll have to rationalize these as well. So in our dividing section, when you have a binomial in the denominator, you're going to need the conjugate to rationalize that or to simplify. So on the top and the bottom, I will multiply by 1 plus 4i. That's going to require foiling on the top and on the bottom. Go ahead, get a step ahead of me.
All right, all of these vectors get connected to the origin on the left. There's 0.56. Okay, and A is B. Okay, and again, you're going to be
There's that I squared again. And there it is again. I don't want you to rush these when you're new to this. Take your time. Look at what happens.
All right, for negative 2 plus 3i, you find the
neatly. Negative 10 plus 11i all over 17. For number 14, let's start by setting this up as a fraction. 8 plus 2i over 4 minus I. Don't even think about reducing here because we have addition and subtraction, so no chopping. We're going to multiply the top and the bottom by the conjugate of 4 minus I. If you look back at chapter 3, rationalizing the denominator, you'll see we did the same thing with radicals. There's that I squared again. So I wonder if you'd noticed when we multiply two conjugates, these middles always drop out. So they dropped out here as well. So the middles will always drop out. You can count on that. This will be negative 2. So I have 30 plus 16i on the top. This will be plus 1 and a 17 on the bottom. If you're subtracting, negative 1, that would be the same as adding it. All right, and number 15. Number 15 doesn't have a binomial on the bottom. It just has a monomial, 2i. It was a little simpler process. I have to rationalize by I over I. Let's put parentheses there. So distributing here, 4i plus 2i squared all over 2i squared. Don't chop. Let's carry this through and see what happens. 4i is 4i. Plus 2i squared will be minus 2. And on the bottom, 2i squared will be also negative 2. So now remember, if your single denominator goes into both parts up here, then you can reduce, and we have that happening. So negative 2 into 4i is negative 2i, and negative 2 divided by negative 2 is positive 1. Now I would turn this around to write 1 minus 2i so that it's in the form of a complex number. Terrific. Let's do the next page. So the next part says multiplicative inverse. Multiplicative inverse of anything is the reciprocal. So the multiplicative inverse of plain old A is 1 over A. So let's write the multiplicative inverse for each of these 4 items. The multiplicative inverse of 12 is 1 over 12. The multiplicative inverse of 3x is 1 over 3x. The multiplicative inverse of the square root of 10 is 1 over the square root of 10. Now we have to rationalize. What will I multiply the top and bottom by? Radical 10, of course. So we have the square root of 10 over 10. And for 19, the multiplicative inverse of 4 plus radical 7 is 1 over 4 plus radical 7. Another radical in the denominator, another problem to rationalize. What are we going to use here? You probably said it. 4 minus the square root of 7. So let's see. In the numerator, 4 minus the square root of 7. And let's see, we would get 16. Drop out, minus 7. Right? And so we have 4 minus the square root of 7 over 9. The bottom line is, when we get these binomials, we have more work to do. So the multiplicative inverse of a plus bi is 1 over a plus bi. And then you have to rationalize. So let's see what they give us. Determine the multiplicative inverse for each of the following in simplest a plus bi form. Excellent. So the multiplicative inverse of 3 plus I is 1 over 3 plus I. The multiplicative inverse of negative 1 plus 4i is 1 over negative 1 plus 4i. Now we have some work to do. Rationalizing requires the conjugate in these cases. Conjugate of negative 1 plus 4i is negative 1 minus 4i. Remember, only change the middle. All right, so you have some work to do. You might want to pause here, check them after the end. We're almost done. On the top, 3 minus I. On the bottom, FOIL, 9, drop out, minus I squared. So 3 minus I, 9 minus negative 1. There's that I squared again. So what we have is 3 minus I all over 10. Beautiful. 21. On the top, negative 1 minus 4i. On the bottom, FOIL, drop out, minus 16i squared. There's that negative 1 again. So we have negative 1 minus 4i all over 1 plus 16. And there we go. Awesome. Multiplicative inverse. Same as reciprocal, but we need to polish them up because they're radicals in the denominator. All right, look at this cute little guy. This is what we just learned. The multiplicative inverse of A is 1 over A. What's an additive inverse? Well, an additive inverse is what you get when you add to A to get 0. So the additive inverse, you guys would probably call the opposite. It's the negation of whatever you have. So, what's the additive inverse of 4 minus 7i? I need to get 0 if I add it to 4 minus 7i. All right, this is going to be a question on your Google form. So go ahead and answer those now. And we will see you Wednesday, lucky kids with a day off. 4 minus 7i. Ciao.